subject control the size of the particles formed in the emulsion process. Last but not least, a few words about conservation. And conservation, presentation of polymers, several polymers for the phase separation. They can be simple and complex conservations. Salting out dehydration of polymer by salt, which is higher in water than the used polymer. And this method will result in the formation of the solid particles or droplets of oil-coated carbon into microcapsules. For the complex conservation, where we have the polyelectrolyte complexes formed with the mixture of two colloids, the pH at which these polymers are oppositely charged. And conservation, we can have, for instance, oppositely charged arabic gum and gelatin. And if they are mixed, we have high separation formation of solid particles or liquid droplets. And just primitive, but I think to me it's a very informative cartoon. This is how it works. The anionic and cationic polymers, and when they make the complex conservate at this place and time, a lot of things can get entrapped into this complex, including our beloved probiotic material. Pros and cons: simple, low cost, large number of cells can be encapsulated, works well with lactobacilli with a decent stability, also at the ambient temperatures. Cons: it's a batch process. It's difficult to scale up, requires additional drying stage, and of course, the bacteria are not that stable as we would love them to be. Coming to the conclusion remarks of this session, and first, giving you some examples. Lozenges. I mentioned it. These probiotic and our beloved Strepsilovirus K12 from John Tag, New Zealand. Chewable tablets. What else? Strepsilovirus again in the tablets, dissolvable tablets, oral strips, toothpaste, mouthwash. All these conditions, all these scenarios, all these type of products where we have probiotic microorganisms, one or another way formulated in the deliverable vehicle, which allows for the microorganism to survive through the production of the product, shelf life storage, application, and to be effectively delivered to the site of action. Some of the polymers used in encapsulation, again, I already mentioned that perhaps the intelligent approach will involve the combination of probiotic and prebiotic, these kind of encapsulations. And this is where we have the microencapsulation with the pro and prebiotic involved. And if we have prebiotic present at the site of action, that's an additional boost for the probiotic to start acting, to work properly. Right? And one of the things that I love to dedicate a standalone session to delivery in a biofilm stage. And this is where you have an example with lactobacillus 3 incubated with dexanomer microsphere loaded with maltose that actually promotes the biofilm formation. You have here the electron microphotograph image of the cells. They're beautiful and they're already attached to the surface of the microspheres, and probiotic in the biofilm state are more resistant to the stresses. All right, and finally, on the third figure, biofilm state can increase intestinal permeability, so improves the integrity can also assist with the control of the necrotic enterocolitis cases. But what I want to say, that there were numerous reports indicating that the microorganisms, when they are delivered as a biofuel, they survive better, and they start working much sooner and much more effective as compared to the microorganisms that are produced through the liquid stage fermentation. And I mentioned it very briefly. I don't know if any of you had a chance to notice it, but when I was sharing with you some of our data on the spore-forming probiotics in poultry, I did say that these probiotics were produced through the solid phase fermentation using soybean as a substrate. So basically, the microorganisms were the probiotic bacilli were grown on the surface of the soybeans, and they were beautiful biofilms formed, and then they were, used to deliver to the poultry. And of course, they were built to make them convenient to formulate into the feed, the bird feed. But microorganisms remain on the surface of the particles in the form of biofilm, and we did do some comparison and showed that these biofilm-associated surface-attached probiotics performed really better than the microorganisms that are produced through the liquid fermentation. Of course, solid state fermentation of the microorganisms is a batch process. Of course, it is more difficult to scale up compared to the fermentation in the liquid environment. But on the good side, on the positive side, you can make it modular. You can produce as much as you need, depending on, for instance, the order by the customer. It is very cost effective. It requires much less energy than the liquid phase fermentation, and the byproducts are almost none. Everything is utilized. So I'm personally very much in favor of solid state fermentation. I want to implant this idea into your brain. Think about it, consider it. There are a lot of opportunities, not only for research but also for application of the microorganisms produced through the solid state fermentation. And with that, I would like to finish our first gathering today. I'm pretty sure that we are on time, and we can also have perhaps some time for a few questions, if there are any. I don't know. I don't see anybody asking questions. So, Dr. Tiwari, you with us? Can you hear me? Anybody? Just let me know.
Yes, sir, you are audible.
Thank you. Pushpa, thank you. And thank you so much. So I understand it's a holiday, everybody's relaxed, and my apologies, I didn't.
Yes, it's raining outside very heavy.
Oh my goodness. Yeah. We're having snow tomorrow, actually. First snow this year. They promise, I don't know if it will be, but they say that maybe snow. Anyway, so I don't know if there are any engineers in our gathering today here. Are there any engineers with us, or only biologists? If there are any engineers, of course, your opinion, what you think about it, is very important for us biologists. And I started working on the delivery systems, I was kind of a blast because I was co-supervising one PhD student who came to my lab from engineering, and she had very solid, good background in engineering. And so first day she came to my microbiology lab, she looked around and she said, "Everything you are doing is wrong." And there was a moment of silence because how comes that we're doing wrong things? We were thinking that we're doing right things. But then this young student, she helped us to start thinking, as engineers, which is very important when, especially you're considering the application of the microorganisms or bioactive substances. Yeah, that was very interesting experience, which also helped with the studying of the delivery systems. One of the delivery systems I didn't mention is, I did mention briefly gels, but I didn't mention much about the nanogels, and actually, to be specific, pegylated nanogels, and nanogels which contain PEG molecules in the structure. And these PEG molecules can all surface outside. They can be branched, they can be used to attach different bioactives, and I was working on the delivery of bacteriocins for vaginal application. And these gels can also be designed in a way that I already mentioned thermogels, changing viscosity, changing from the solid to fluid at different temperatures. Imagine how this is important. It's important the ambient temperatures then delivered to the vaginal environment where the temperature is of the human body, and it's changing the physical parameters of the delivery system. And again, I was working with a chemist who wanted to attach molecules to the PEG, which was facing outside. And it didn't work, but the efficiency was relatively low because there are only a certain number of molecules you can have. And I looked at it and I said, again, this is thanks to this student, to the girl who came from engineering. And I said, why do we need to attach? Cannot we just mechanically interact between these, hairy structure of PEG molecules, and mechanical entrapment worked really beautifully. I didn't mention foaming as a delivery tool, and foaming nowadays is becoming, foaming agents is becoming really very interesting and encouraging method, especially when we are dealing with the delivery of substances to the very complex geometry profile environments, such as, for instance, vaginal environment. And this is where the foaming delivery systems may be really very effective. With regard to the gels, when the gel is forming the film at the elevated temperatures from ambient to the body temperature, and this gel transferred into the film, attached tightly to the surface of the vaginal epithelium, stays there. And we did some studies where we took a mouse and injected the mouse vagina with this gel, and then the mouse was slowly rotated all the possible and impossible directions, almost as a trainee for the space mission. And it was staying firmly in the vaginal environment, and the delivery was fantastic, the delivery of bioactives. With that, we finished. Dr. Tiwari, I hope he is with us, perhaps just left on the break, a short break, and I will start the second session. And as we were told, we have another meeting today, and let me share with you the bacteriocins. Okay, last but not least, of you who are with us today, you are true heroes. I appreciate it. I hope it will be useful for you. Last one, we're going to talk about what is really close to my heart and what is close to the heart of Dr. Tibari. And I hope some of his colleagues are also with us. Don't expect, those of you who are familiar with bacteriaceae, don't expect anything, as eye-opening, because you must know this stuff. But yeah, I will introduce us into the field. I will give you the idea about the generic operon organization and the mode of action. We will look at some examples of bacteriaceae in food products. We will expand applications and work briefly about the multiple hurdle approach, which I think is the key approach, the key strategy. We'll look beyond the killing, control of biofilm formation, and we briefly touched upon it with emphasis on probiotic bacteria. But hey, what is working there? Most likely, first bacteriaceae delivering their action. We will again escape food, and then we will conclude by talking about the crossroads, challenges, and where we are and what needs to be done. And of course, probiotics, what they do, immunomodulation, regulation of endocrine system. It's just the last song because we are about to depart. It's a farewell song, if you wish. Okay, regulation of central peripheral nervous system, but of course, antimicrobial activity, and that can be done through competitive exclusion, and there are a variety of methods. Competition for nutrients, attachment, production of antimicrobials. Bacteriaceae are one of the potent group of antimicrobials that are produced by virtually all microorganisms. We need to look at the definition. Apologize to those who know the field. Maybe a little bit boring for you guys, but the most important thing that bacteriaceae are ribosomal synthesized. It's important to mention because there are also antimicrobial proteins that are secondary metabolites, and we'll see examples like polylysin is one of them, which is produced by soil microorganisms that has rest status, and I think it will be mentioned in one of the upcoming slides. Okay, number one, ribosomal synthesized. Number two, relatively small size, all the bigger size molecules exist, which fall into the category of bacteriaceae, but mostly small size. Mostly active against closely related microorganisms. But there are some that are active against different bacteria that are not relatives. Even bacteriaceae from gram-positives can be active against gram-negative bacteria. Just a few examples, but they do it. They can also be involved in signaling and work as quorum sensing, quorum quenching molecule. So where is the place of bacteriaceae in the family of the natural antimicrobials? And you can see they can be divided roughly non-proteinaceous, proteinaceous nature, and complex organized antimicrobials where we have bacteriophages. And we're not going through weak organic acids, terpenoids, curcumins, deuterines, proteinaceous nature, lactoferrin, lactoferricin, lysozyme are used also in for preservation processes. But proper origin. I mentioned polylysin, right? And it has brand status for several applications, by the way, affirmed by the FDA. Ribosomally synthesized bacteriaceae, and niacin A is one of the examples. John Tagg, at least I've heard from him sometime in the last millennium, 1991, around that. The virtual bacteria produced bacteriaceae our task is to discover and study that. These are the words that I've heard from the guru, right? And he is one of the gods of bacteriaceae. A very important thing to keep in mind is that bacteriaceae are not antibiotics. I'm not saying that they cannot be used as antimicrobial agents in medical applications. Yes, they can. Hopefully they will. But they are not antibiotics. Right now, we don't have any clinical applications for bacteriaceae, but they are used in foods. Ribosomal synthesized, while antibiotics are mostly secondary metabolites. That some of them ribosomal synthesized, but just very few. Mostly narrow spectrum activity as opposed to antibiotics where we have broad spectrum of activity. There is house cell immunity with a variety of mechanisms, and we'll see some examples today, and no such thing in the case of antibiotics. Target cell can become resistant through the adaptations, mutations, causing different changes. Many of them involve the cellular membrane, and in the case of antibiotics, we have different response from the targeted cell and from the producers. Interactions required, we say here sometimes docking from the recognition side. And I think these kind of docking sites, my personal feeling, they exist for all bacteriaceae. And again, we have to discover them. All right, and for antibiotics, there are specific targets in the cell. Mode of action, many of them, maybe most of them, act on the membrane. They can cause the turbulency in the membrane without pore formation. They can cause pore formation. They can work on other things in the membrane, inside the cell, leading activities that we will talk about. Cell membrane targets are for antibiotics, toxicity side effects. This is one of the most important things. Up to today, I didn't see never any report of side effects or toxicity from bacteria study. Now, and with antibiotics, of course, they're saving our lives, but when you open the leaflet, you have few lines of what it is and what it does, and then fine print, maybe 5 times smaller letters and 5-10 page possible side effects. It's a cost we have to pay to survive. Bacteriaceae can be, and they are classified based on a variety of approaches, and different classifications for the gram-positive and gram-negative microorganisms derived bacteriaceae. For gram-positive, 1, 2, 3, 4 classes, and you can see antibiotics, non-antibiotics, so basically containing unusually modified the class 3 larger size, and even those that contain the lipid or carbohydrate structure. For gram-negative, we have cholestins, like we have micros, and we have far paler line type of urea. Cholestins perhaps are the first discovered information for the bacteria from Archaeobacteria, and this is where I will point your attention to Dr. Green, who is working on bacteria. He knows this stuff, and since we are dealing a lot of times with lactic acid bacteria, through the course of our today's and previous sessions, I'm giving you a really very good classification of the bacteriaceae from MLAs, and co-workers suggested the senior author Oscar Gilbert from the Chronic Kidney University. I think he retired this year, but he's still a very active professional. Again, one of the gurus of bacterial research. And you can see 3 classes modified peptides, they're with psilocybin A, which I love very much, and I'm talking about it a lot. Class 2 unmodified P1 interest, and I love personally immensely because I worked with it so many years, and I always give examples of these kind of studies. 2 peptide from lactobacilli. You may remember we were talking about 2 peptide bacteriaceans when dealing with the of the model studies controlling obesity, and that's from the Irish group, University College Cork, Hiagas, and other colleagues. So, some examples of bacteriaceans, and the reason I put together these table is to show